Now that you're done making your graph on LoggerPro, the next step of your lab report is to find the average line of best fit from your max and min lines of best fit. So a line of best fit is a straight line that best represents the data on a scatter plot. The line does not have to pass through every point to best represent the pattern of the data. So you can see that even though this line that's drawn on this data is not actually physically passing through every point, it still does a pretty good job of predicting where that data is going to appear. So that's the goal for a line of best fit. The goal for a lab report in general is to predict what will happen in the future, or predict what will happen for quantities that you haven't tested yet. And the way that you can do that is by using a mathematical line like this to find what the value of that line will be for quantities that you haven't tested. This is another example of a line of best fit. One thing to say before we start, if you're drawing your physical graph on your lab report, do not connect the dots on your graph. This is completely meaningless and gives us no useful information at all. So please don't do that as you're drawing this. So by now you've added error bars onto your LoggerPro graph, and those error bars create areas of uncertainty where your data could possibly be. And you've drawn a maximum line of best fit through those areas of uncertainty, and you've drawn a minimum line of best fit as well, lines that have the largest possible slope and the smallest possible slope that can still fit through most of those areas. So our idea is that if that's the biggest possible line you can get out of this data and the smallest possible line you can get out of this data, the most reasonable estimate for what your data is actually doing, the line that your data is actually on, would be something right in between the minimum line and the maximum line. So if we can find the average of those two lines, then we'll have the best estimate that we can get of what your data is actually doing. So now we just need to understand how to actually take the average of two lines. So the first step in taking the average of two lines is to write the equation for both lines. There's a space on your lab report that looks like this. This is where you're going to physically copy down the equation for each line. And to get the equation for each line, you're going to need to use LoggerPro. These four spaces specifically are where you're going to fill in the information that you get from LoggerPro. Everything else you can fill in from previous parts of your lab report, but these four spaces you're going to need to use the equations that you got for that maximum and minimum best line, for that maximum and minimum best fit line. So the boxes for the manual fit lines that give you the slope and y-intercept for the max and min lines look something like this on LoggerPro. So you're going to take the slope of your maximum line and the y-intercept of your maximum line and put them here and here, and the slope of the minimum line and the y-intercept of the minimum line and put them here and here. You'll notice that most of the time the y-intercept of the minimum line is actually going to be larger than that of the maximum line. This makes sense if you think about it as having the smallest possible slope. So I'm going to copy down these numbers here. And you don't have to copy down every single number that LoggerPro gives you. Round to a reasonable number of significant figures based on your original measurements. Okay, this is everything that you have to fill in. The y variable is just another name for the name of the dependent variable. The units are the units that dv is measured in. The slope unit is going to be the dv unit over the iv unit, just because slope is rise over run. And on a graph like this, we're measuring the dv on the y-axis and the iv on the x-axis. So the slope units will be the units of dv over the units of iv. The x variable is the independent variable, so you'll just copy down the name of that variable, and the x unit is just going to be the unit of IV. And finally, the y-intercept units are also going to be the dv units, the dependent variable units, because if you think about it, the y-intercept is going to be measured using the units of the y-axis. So I'm going to imagine that we're comparing displacement and time. So displacement measured in meters is our dependent variable, and time measured in seconds is our independent variable. So those would go where they go. You can see that the slope units are the unit of the dv over the unit of the iv. So here that would be meters in the numerator and seconds in the denominator. So that's how we would fill out the equation for the maximum and minimum curves of best fit. Okay, the next section of the lab report asks you to find the average of the slope in the y-intercept and the absolute uncertainty of the slope in y-intercept, and sometimes it will also ask you for the percent uncertainty of one or the other. These are the equations that you need to use for each one. These equations are also given to you on the left in those boxes. You can see as an example below average value, it shows sum over the number of values. That's the equation for the average of numbers. I'm just giving them to you like this so it's a little more clear what you have to do. So you can see that as an example, to find the average slope, you add the slope of the maximum line plus the slope of the minimum line divided by 2. So it's literally the mathematical average of the two slopes from your experiment. And the absolute uncertainty is going to be the largest slope minus the smallest slope divided by 2. Based on how we've been using uncertainty in previous parts of the class, that makes sense. It's just half of the range of the possible values that that slope could take. If I take that max and min line of best fit equation that I got in the previous slides and plug in the slopes and the y-intercepts to their correct spots, these are the numbers that I would get for each value. Finally, the percent uncertainty of the slope is just the absolute uncertainty divided by the average slope times 100. So I'm just going to take those numbers and multiply them by 100%, and that will be my slope uncertainty. So here it's 22% uncertain. The next step is to get the average best fit equation itself. And this is kind of one of the big central goals of the lab report. If you can get an equation that tells you what value your dV is going to take for any IV, you've found a way of basically predicting anything that will happen in your experiment, which is a pretty big accomplishment. The goal of all science is to predict things. The goal of physics specifically is to predict motion. And so if you have an equation that can make a prediction for any independent variable and tell you what the dependent variable will be, that's a huge accomplishment. So let's see how we fill in this average curve of best fit equation. This is what you're going to put into each section. The y variable is the dependent variable. The y units are the dv units. The slope of this average line of best fit is going to be the average slope that you calculated in that previous section. The slope uncertainty is going to be equal to the absolute uncertainty of the slope. The slope units are the dv unit over the iv unit. The x variable is the independent variable. The x units are the units of the independent variable. The y-intercept is going to be that average y-intercept that you calculated. And you're also going to include the y-intercept uncertainty and the y-intercept units. So here, these are the units that I used in my experiment, and these are the numbers that I got from the previous section. So this would be my average curve of best fit equation. This equation is telling me that if I plug in any time, I can multiply it by 3.2 plus or minus 0.7 meters per second, add negative 0.7 plus or minus 4.3 meters, and that's going to give me a specific displacement as a result. And so that's how you create the average line of best fit from the maximum and minimum lines of best fit that you get from Logger Pro.